the tangent theorems. So we've looked at the first 4 circle theorems, and now we're going to look at some tangent theorems. We will start with this one, the alternate segment theorem. So we look at this diagram here. You have a tangent which touches a circle, because a tangent does touch the circle, but the important bit here is the tangent touches the circle at the same point as a triangle. So when you've got a triangle within a circle touching a tangent from one of its corners, the angle here is equal to the angle in the opposite length of the triangle. So let me just go through that in a bit more detail. So you see this tangent touches this length here to make an angle, right? See that angle that's made, that yellow angle, by the tangent touching that length of the triangle. If you look at the opposite angle to that length, those angles are the same. And it's the same from the other side as well. So we have the tangent touching this length of my triangle to make an angle here, and that's equal to the opposite angle in the triangle. Okay, so let's just have a go at these 3 together maybe, and then you can have a go at some questions yourself. Okay, so for this first one, the tangent touches this length of your triangle to make an angle of 80 degrees. So let's look opposite to that length, so A is 80. And then just come in from the other side. We have the tangent touching the triangle to make an angle. So B is equal to the opposite angle to that length of a triangle, so 44 degrees. So here we have a couple of circle theorems going on. You've got a diameter within a triangle within your circle, so that's 90 degrees. Angles in a triangle add up to 180. So our missing angle, is 54 degrees. And then we have this length touches this length to make an angle D. The opposite angle is 54, so D is 54. And then just come in from the other side. Here touches this length to make the angle C. Opposite one is 90. And for this one, this last one, we have E is made there. That's equal to this one, which we don't know yet, but it is an isosceles triangle. So those angles there are the same. So 180 take away 68 divided by 2 gives us 56. Okay, have a go at these ones yourself. Put me on pause, unpause when you're done. So X and 70 are the same. I feel like it helps highlighting. So if you want to print screen the page, do it that way. Y is 60. And then from the other side, X is 55. Opposite angle X, 65. Opposite angle y, 63. So you could either do angles on a straight line or angles in a triangle, add up to 180, 52. Opposite angle x, 67. Opposite angle y, 64. We've got an isosceles triangle here, so A is 81. Angles in a triangle add up to 180. 180, take away 2 lots of 81, gives you y is 18. So we have so far A is 81, y is 18. Then we have the alternate segment theorem. X is 81. And the alternate segment theorem, Z is 81 also. Okay. I can see an arrow theorem here. Also, did you spot we have radius? So we've got an isosceles triangle. But I will start with my alternate segment theorem. So now that angle 80 touches the triangle. The triangle you're looking at needs to touch all corners of your circle. X is 80. Arrow theorem, angle at the centre is double angle at the circumference, so y is 160. And then we have an isosceles triangle here. So to get z, 180, take away 160, divided by 2. Okay, so even though we only looked at 4 circle theorems before, don't forget I had my number 5 not a theorem. So we've got 6, 7, 8, and 9 are our tangent theorems. Let's just look at these. 7, we've discussed the alternate segment theorem. 6, the angle between a radius and a tangent is 90 degrees. So if you ever have a radius touching a tangent, it is 90 degrees. Number 8, the tangents to a circle from the same point will be equal in length. So as you can see here, 2 tangents touch at the point C. They're equal in length. So this is useful. If you had a triangle here, we would know it would be an isosceles triangle. And here, this one does not come up very often, but the radius, there's your radius in red, through the midpoint of a chord. So there's your chord. If the radius goes through the midpoint of a chord, it will bisect the chord at 90 degrees. Okay, we'll look at a few together, looking at the tangent theorems. So for 10a, we have a radius touching a tangent, so that has to be 90 degrees. And in which case, angles in a triangle add up to 180, so x is 63. Same here, we've got a tangent touching a radius, 90 degrees. Angles in a triangle add up to 180, so x is 22. Okay, so here, right, we've got a tangent touching a radius. I'm going to put that on as 90 degrees. Tangent, sorry, that is your tangent touching the radius, 90 degrees. Now we've got a 4-sided shape. Angles in a 4-sided shape, angles in a quadrilateral, add to 360. This is not a cyclic quad because all 4 corners of your quadrilateral do not touch the outside of your circle. But we know all the angles in a quad add up to 360. So let's take off both your 90s and your 158 gives us x is 22. Really the same idea for 2. Tangent touching a radius, tangent touching a radius. Gives us x is 165. Okay, now here we need theorem 8. So your tangents to a circle from the same point will be equal in length. So we know that's an isosceles triangle. So I can say already these are 180, take away 36 and divide it by 2, 72 degrees. We also know that we've got a tangent touching a radius, which makes 90 degrees. So that whole angle there is 90 degrees. So to get x, it is 90, take away 72, which is 18. Okay, those are all the tangent theorems completed. Let's just now, I would suggest watching my recording on exam questions where we look at all the theorems put together.